There are moments when the universe seems to lean closer, moments when the sky itself feels alive, whispering secrets that are too vast for human language, yet too precise to dismiss as mere chance. The last week of September 2025 was one of those moments. To most people on Earth, it was an ordinary stretch of days. Deadlines, commutes, small victories, small worries. But beyond the fragile dome of our atmosphere, the cosmos was arranging a performance so intricate, so improbable, that even the most disciplined scientists were left staring at their data in silence, wondering if the universe was trying to send a message. It began with fire. Not one, but two stars, light years away, erupted in violent thermonuclear explosions. In distant constellations, nova flares burst forth, hurling invisible storms of X-rays and gamma radiation across the emptiness. In the vacuum of space where silence reigns, these signals of destruction raced outward at the speed of light. Days later, their echoes arrived in our neighborhood, bathing the solar system in high-energy photons. Most of these photons passed unnoticed, absorbed by planetary atmospheres, swallowed by magnetic fields, or dissipated in the thin interplanetary wind. But for those watching carefully, the timing was impossible to ignore, because just as the nova light reached us, another actor stepped onto the stage, Comet SWAN. At first, SWAN had been a faint wanderer, a smudge of ice and dust that only astronomers cared to track. But on September 26th, it erupted without warning. Its coma, the cloud of vapor around its icy heart, swelled with sudden fury. Its tail, once modest and delicate, surged outward until it spanned more than 2 degrees across the night sky. Imagine 5 full moons lined up side by side. That was the length of SWAN's luminous banner, stretched like a glowing river across the darkness. In a matter of hours, an anonymous comet became a spectacle. Coincidence, the skeptics said. Stars explode all the time. Comets flare when sunlight penetrates fresh reservoirs of volatile ice. Nothing more than timing. Nothing more than chance. But the cosmos was not finished. 2 days later, September 28th, 0843 Universal Time, the Sun itself unleashed its own violence. From active region 4232, a tangled nest of magnetic fields, an M-class solar flare erupted, the most powerful in 3 months. Satellites orbiting Earth recorded the surge. Instruments screamed with high-energy noise, and radio waves on our planet's sunlit side briefly fell into silence. And then, as if that weren't enough, a coronal mass ejection, 1 billion tons of magnetized plasma, burst outward, traveling at nearly 2 million miles per hour, racing into the same region of space through which Comet SWAN was drifting. Think about the timing. 2 novas, then the comet, then the sun, like notes in a symphony, like movements in a dance. Each separated by only days, each aimed somehow toward a convergence that statistics alone struggle to justify. Reason tells us it's coincidence. Reason insists that randomness produces clusters, that our brains are simply pattern-hungry machines finding design in a storm of noise. Yet reason also demands honesty. When events align too neatly, even the most cautious scientist must pause, if only for a moment, to consider whether something deeper may be at work. And so September 2025 has become a riddle. Are we watching the ordinary chaos of space, events colliding only in human imagination? Or are we glimpsing the outlines of an interwoven system, a hidden circuitry of energy that connects novas, comets, and stars in ways we have only begun to imagine. Let us walk slowly into this mystery. Picture SWAN once again, fragile, ancient, 4 billion years old, a remnant of the solar system's birth. On September 12th, it had already passed perihelion, its closest approach to the Sun. It should have been settling into routine behavior, fading quietly as it retreated. Instead, it flared, brighter, wilder, unpredictable. It is easy to dismiss comets as dirty snowballs, lumps of ice and dust crumbling under sunlight. But comets are also laboratories. Each eruption exposes chemistry older than Earth, each tail a record of plasma physics written across the sky. SWAN's outburst wasn't just brightness, it was transformation. Its coma became electrically active, interacting with the solar wind in ways that suggested it was no longer just a visitor, but a participant in a grander system. 2 days later, the Sun seemed to respond. Did it notice? Of course not. The Sun is a cauldron of plasma, its eruptions driven by forces far beyond the nudge of a comet. Yet the timing feels like theater. 48 hours from comet's awakening to stars' retaliation, as though nature were counting beats. The coronal mass ejection, too, was no random spray. Its trajectory, while not aimed at Earth, was aligned with the orbital path of the comet itself, as though plasma sought plasma, as though the Sun's fury knew its mark. This is how myths are born. This is how humans, staring upward for millennia, learn to tell stories about gods and destinies written in the stars. But today, unlike our ancestors, we hold instruments that measure photons, detectors that read magnetic fields, satellites that monitor plasma in real time. And those instruments agree on one fact. September 2025 gave us a pattern that cannot be easily ignored. Still, scientists must be careful. No causal chain has been proven. The nova radiation, though powerful, was faint by the time it reached us, billions of times weaker than sunlight. The comet, though active, is a grain of dust compared to the Sun's mass. The flare, though precisely timed, may have been inevitable. Mainstream astrophysics places guardrails on speculation. Coincidences happen, and they happen often. But what if this was not coincidence? What if, just this once, the universe revealed a glimpse of its hidden scaffolding, the electromagnetic bridges that link stars, comets, and planets in a web of invisible currents? This is the question, and it leads us to October 21st, the day of convergence. By then, Comet SWAN will be closest to Earth, just 10 million miles away, a distance both vast and intimate. The night will be dark, the moon will be new, its light erased from the sky, and hidden behind the sun's glare, a more mysterious traveler approaches. 3I Atlas, the third confirmed interstellar object ever discovered. Like a messenger from beyond, it races toward perihelion, destined to skirt inside Mars' orbit, carrying with it the secrets of another star system. SWAN and Atlas, two wanderers, one native, one alien, arriving in the same weeks, embedded in the same turbulent plane of solar magnetism. If this is chance, it is beautiful. If it is design, it is profound. And so the stage is set. The curtain is rising, the actors are in place. Nova, comet, sun, and interstellar traveler, a cast assembled across light years and eons. Whether choreography or chaos, the performance has begun. The only question left is, are we ready to listen?
Welcome. You are watching Whisper Science. Make sure to subscribe and join us for more amazing science content. Now, let's move back to the video.
The night of September 26th began without warning, quiet and unremarkable for most of the world. But for astronomers in the southern hemisphere, scanning the skies with modest telescopes and patient eyes, something extraordinary unfolded. Comet SWAN, once a faint smudge, a shy visitor, suddenly blazed to life. Its coma brightened, its tail expanded, and the whispers of cosmic mystery grew louder. Within a matter of hours, SWAN's brightness leapt from magnitude 6.5 to nearly 5.7. For the untrained ear, those numbers may seem meaningless, but in astronomy, they represent a leap from invisibility to spectacle. Under dark skies, magnitude 6 marks the faintest star the human eye can see. Magnitude 5 is a star that anyone can notice, even from a quiet field far from city lights. In that narrow leap, SWAN crossed the line between anonymity and revelation. The tail too changed in ways that demanded attention. Previously, it had been a fragile streamer, visible only to cameras and long exposures. But now it stretched across 2.5 degrees of sky. To grasp that size, hold out your hand at arm's length. The spread of your fingers spans roughly 20 degrees. SWAN's tail alone covered 1/8 of that span, a river of dust and plasma flowing across the heavens. Not just a comet anymore, but a herald, a sign written in luminous gases. For astronomers, comets are unpredictable companions. Some pass quietly, fading into history without notice. Others flare spectacularly, becoming legends in human memory. Hale-Bopp in 1997, Lovejoy in 2011, and now perhaps SWAN in 2025. Each eruption is a reminder that comets are not dead relics but fragile, volatile bodies, alive in their own way, carrying the chemistry of the solar system's birth inside their frozen hearts. But SWAN's awakening was more than just brightness. It was transformation. The comet shifted from a cold body of ice and rock into an electrically active participant in the drama of space. As its icy crust cracked and gases poured into the void, ultraviolet light from the sun ionized those molecules, charging them, turning neutral atoms into plasma. This plasma wrapped around the comet like a cloak, a glowing envelope capable of interacting with the solar wind itself. And this is where the story deepens. The region through which SWAN traveled was no ordinary place. It was the heliospheric current sheet, a vast undulating boundary stretching outward from the sun like a ballerina's skirt, rippling as it spun. Here, the sun's magnetic field flips polarity, creating a landscape of electromagnetic turbulence. Streams of charged particles, currents of plasma, invisible rivers of magnetism flow through this space, shaping everything that passes through it. For a comet, this environment is both danger and opportunity. The gases it releases become ionized, feeding the current sheet, altering the local plasma density, changing the balance of forces in ways that are complex and still poorly understood. Scientists call this mass loading, when new material enters the solar wind, adding particles, slowing flows, bending magnetic lines. In most cases, the effect is minor. But with SWAN's sudden eruption, mass loading became significant. The comet wasn't just drifting through space anymore. It was stirring the medium, disturbing the currents, perhaps sending ripples that could propagate far beyond its immediate surroundings. This idea might sound fanciful, but plasma is a strange and unpredictable state of matter. Unlike solid, liquid, or gas, plasma is alive with charge and currents. It can twist, fold, and self-organize. It can store energy in magnetic fields and release it explosively. And when dust mixes with plasma, the dusty plasma of comets, the behavior becomes even more exotic. Charged grains of rock and metal can bend electric fields, change flow dynamics, and sometimes behave in ways that defy the predictions of classical magnetohydrodynamics. In laboratories on Earth, dusty plasmas have formed spirals, waves, even patterns that resemble living cells. In space, around comets, they may create structures that are vast, dynamic, and still mysterious. When SWAN erupted, it created not just more light, but a laboratory, a natural experiment unfolding millions of miles away. The comet was no longer a silent traveler. It had become an electrode, a plasma source embedded in the solar wind, capable of feeding energy into the vast electrical circuit of the heliosphere. And yet, here lies the mystery. Its eruption coincided with the novas and preceded the sun's flare. Did SWAN merely respond to solar heating, random cracks in its icy crust? Or was its timing nudged by forces more subtle, radiation from distant stellar explosions, a slight increase in local ionization, a trigger that pushed the comet over its threshold? Consider this. Comets are exquisitely sensitive. A minor shift in heat, a small burst of radiation can change their behavior. They are fragile, unstable, ready to erupt with little provocation. So when two novas bathed the solar system in high-energy photons, is it impossible that SWAN felt their touch? That radiation penetrated its icy crust, warming pockets of volatile gases buried deep inside, creating pressure that hours later erupted into a storm of brightness. The energy calculations argue against it. Nova radiation at Earth's distance is minuscule compared to the sun's heat, yet timing whispers otherwise. Days after the novas, SWAN awoke. 2 days after SWAN, the sun erupted. A chain reaction or coincidence? The mind rebels at randomness when patterns align so neatly. For observers on Earth, the effect was beauty. In southern skies, SWAN's new tail stretched like a sword of light. Photographers posted images online, the comet glowing against the black, a pale reminder of the solar system's restless nature. But for scientists, the questions multiplied. If SWAN's plasma could disturb the solar wind, could it send ripples back toward the sun? Could mass loading in the current sheet create instabilities that nudge solar active regions toward eruption? The mainstream answer is no. The sun is too vast, too powerful, too indifferent to notice the faint whisper of a comet. Active regions build tension for days, their eruptions inevitable, independent of any external influence. Yet plasma physics is full of surprises. Small triggers can sometimes unleash vast consequences if the system is already near its breaking point. A grain of sand can start an avalanche. A spark can ignite a storm. And so the speculation persists. Did SWAN's awakening contribute in some way to the solar flare that followed? Did the comet's plasma, interacting with the current sheet, propagate disturbances back toward the corona, arriving at just the right moment? Or was the timing nothing more than chance, a story we tell ourselves in the face of chaos? In either case, the result was the same. SWAN became more than a comet. It became a symbol, a participant in a cosmic drama, its outburst marking the middle act in a sequence of events that has drawn human attention like moths to flame. And the story was far from over. Because as SWAN blazed in the southern skies, another visitor lingered unseen. 3I Atlas, the interstellar wanderer. Hidden behind the glare of the sun, invisible to Earth's telescopes, it was racing toward perihelion, its trajectory almost too perfect. SWAN and Atlas, both embedded in the current sheet, both approaching moments of maximum activity, both timed with the new moon of October 21st. Coincidence or choreography? The weeks ahead would tell. The universe had set its stage, placed its players, and written the first movements of its symphony. All that remained was to watch, to measure, to wait for the curtain to rise on the climax. And so, as September gave way to October, astronomers prepared. Telescopes aligned, satellites listened, cameras pointed. And humanity, once again, found itself waiting for the sky to speak. The sun is not a gentle star. From a distance, its light feels steady, warm and nurturing, the heartbeat of life on Earth. But up close, it is a boiling ocean of plasma, churning with violence, its surface scarred with magnetic storms that twist and snap like invisible whips. For centuries, humanity saw only the calm. With the naked eye, the sun is unchanging, a white disk impossible to stare at for more than a heartbeat. Yet through telescopes, through satellites, the illusion collapses. The sun is chaos embodied. And on the morning of September 28, 2025, that chaos spilled outward. At precisely 0843 Universal Time, active region 4232, a cluster of tangled magnetic fields twisting near the Sun's equator, erupted. The flare was categorized as an M-class, second only to the most violent X-class explosions. In the spectrum of solar tantrums, it was formidable, a release of energy equivalent to billions of nuclear bombs. Instruments aboard NOAA's GOES satellites recorded the surge in X-rays. Earth's upper atmosphere absorbed the radiation, disrupting shortwave communications, silencing radio operators across parts of South America and Africa. For 10 minutes, signals vanished into static, a reminder that the sun is not merely a star, but a restless overlord, capable of reaching into our daily lives with invisible fingers. But the flare was only the beginning. 20 minutes later, coronagraphs aboard the SOHO and Stereo spacecraft captured the unmistakable signature of a coronal mass ejection, a CME. Like a scar torn open on the sun's surface, 1 billion tons of charged plasma burst outward, expanding into space at nearly 900 kilometers per second. It was not Earth-directed. Our planet was spared a direct hit. Instead, the CME tore through the heliospheric current sheet, the same region where Comet SWAN was drifting, its coma still expanded from the eruption days earlier. Think of it, the sun hurling a storm of magnetized plasma into the very corridor where a newly awakened comet floated. Plasma meeting plasma, energy colliding with energy. The choreography felt too exact to ignore. In scientific terms, CMEs are vast magnetic bubbles, spheres of plasma threaded with twisted field lines. When they strike planets, they trigger auroras, disrupt satellites, and sometimes collapse power grids. When they encounter comets, the results are stranger still. History offers clues. In 2007, a CME slammed into Comet Enki. Astronomers watched in astonishment as the comet's tail was literally severed. The plasma bubble swept across the comet's wake, slicing the tail from its body as if by a cosmic sword. For days, Enki drifted tailless, its severed streamer left behind, a ghostly remnant in the void. And in 2014, comet Siding Spring grazed past Mars, just as the red planet was engulfed in the shock front of a solar eruption. Instruments detected ionization storms in Mars's upper atmosphere, triggered by cometary dust interacting with solar plasma. Two separate bodies, one planetary, one icy, caught in a single solar tantrum. Now in 2025, SWAN drifted in the CME's path. Its coma, already swollen with gas and plasma, braced for impact. What would happen? Would its tail be severed as Enki's had been? Would its plasma feed instabilities amplifying the CME's turbulence? Or would the two simply pass through each other, indifferent, unaltered, like ships crossing in the night? Astronomers debated in real time. Some argued the scale was too mismatched, a comet a few kilometers across against a plasma cloud millions of kilometers wide. Others noted that comets, while small, can create vast magnetotails, invisible but real, stretching millions of kilometers downstream. When a CME encounters such a structure, the interaction can be dramatic, producing radio bursts, magnetic reconnections, sudden transformations of plasma dynamics. For Earthbound observers, the evidence was partial. Cameras tracking SWAN showed fluctuations in brightness, subtle ripples along its tail. Radio telescopes detected faint whispers, emissions that might have been linked to the CME's passage. The story was incomplete, fragmented, waiting for analysis that would take months, even years. But the impression was clear. The sun had responded. And this is where imagination rises. Was the sequence truly random? Two novas, then the comet, then the solar eruption, like beads on a string, timed too closely for comfort? Or was the sun merely reaching a breaking point, its flare inevitable, the comet irrelevant? Physics leans toward indifference. The sun's magnetic fields twist and knot for days, their tension bound to release. Comets are tiny, incapable of influencing a star's million-kilometer-wide corona. Yet physics also allows for tipping points. Complex systems often require only the faintest nudge to cascade into chaos. Could SWAN's plasma, a fresh injection into the current sheet, have provided that nudge? It is impossible to say. And yet the coincidence demands attention. Because in the days that followed, the pattern deepened. Comet SWAN, now marked by the storm, continued its march toward Earth's vicinity. The sun, agitated, released smaller flares as if unable to return to calm. And behind it all, hidden interstellar Atlas drew nearer, a shadowed wanderer closing in on its moment of revelation. For those watching, the sense of theater grew stronger. Astronomy is often a patient science, data, numbers, charts, probabilities. But in these days it felt like myth. SWAN as the harbinger, the sun as the roaring god, Atlas as the alien messenger. A play written across millions of miles, but timed so neatly that even the most disciplined mind felt the pull of story. And perhaps that is what the universe offers us. Not answers, but narratives. Not equations alone, but patterns that whisper meaning. To some, that meaning is divine. To others, it is chance. To all, it is irresistible. But the climax had not yet arrived. For October 21st loomed, a date that grew heavier with each passing day. SWAN would be at its closest. The moon would be dark. Atlas would reach perihelion. The stage would be complete, and humanity would watch, waiting to see whether the cosmos would deliver revelation or silence. While Comet SWAN blazed across southern skies, its luminous tail stretched like a cosmic banner. Another traveler was approaching, unseen, unheard, almost unnoticed. Unlike SWAN, this wanderer did not belong to our solar system. It carried with it the silence of another star, a fragment of an alien system hurled into the void long before humanity existed. Its name was 3I Atlas, the third confirmed interstellar object in human history. Where SWAN was fragile and luminous, Atlas was dark and elusive. First detected only months earlier, its trajectory revealed a truth that shook astronomers with a strange mixture of wonder and unease. It did not orbit our sun. Its path was hyperbolic, a curve too steep, too fast to be bound by solar gravity. Like its predecessors, Oumuamua in 2017 and Comet Borisov in 2019, it was passing through, a messenger from another neighborhood in the galaxy, visiting once and vanishing forever. Atlas was faint, its light easily drowned in the glare of the sun, yet its significance was immense. Every interstellar object carries secrets of a distant birthplace, the chemistry of alien dust, the fingerprints of a foreign star, the memory of collisions and forces beyond our own system. To capture even a glimpse of such an object is to hold a piece of another world. And yet the timing defied belief. Atlas was due to reach perihelion, its closest approach to the Sun, on October 21st, 2025. The exact day when SWAN, too, would be nearest to Earth. The same night when the Moon would be absent, its face turned away, leaving the heavens dark. Two comets, one native, one alien, converging in visibility, their appearances framed by novas and solar storms. The odds were astronomical. Coincidence, the cautious insisted. The galaxy is full of debris. Interstellar objects pass through our system regularly. We simply lack the instruments to detect most of them. SWAN's activity, Atlas's timing, the flare's eruption, nothing more than overlapping patterns, meaningless in the grand scale of randomness, but others whispered of choreography. Imagine the symmetry, a comet born in our own Oort cloud, carrying the memory of the solar system's birth flaring, just as a wanderer from another star arrives, both framed by the sun's storms, both aligned with the darkness of a new moon. Atlas itself was strange. Unlike Oumuamua, it was not a tumbling shard of rock. Unlike Borisov, it was not a typical comet. Its brightness fluctuated erratically, as if jets of gas burst irregularly from beneath its crust. Its surface reflected light in unusual ways, suggesting an albedo unlike most solar system bodies. To some, it looked fractured, perhaps even fragmented, a body breaking apart under stresses of solar heating. Yet its persistence was undeniable. Even wounded, it pressed forward, rushing toward the sun in a final blaze before it vanished back into interstellar darkness. For scientists, it was a once-in-a-lifetime opportunity. Proposals raced through observatories. Could telescopes capture spectra of its gases, revealing chemistry untouched since another star's formation? Could spacecraft pivot to glimpse its shape, its surface, its motion? The practicalities were grim. It was too faint, too close to the sun's glare, too fast to chase. Yet the dream lingered, to touch even briefly the material of another system. For storytellers, it was something else entirely. SWAN was the herald, the sun, the roaring god, and Atlas the messenger. Together they formed a trinity, past, present, future, our system's memory colliding with another's fragment, framed by stellar explosions that came from light years away. A stage too perfect, a performance too elaborate to ignore. And then came the speculation. What if interstellar objects are not random debris? What if their timing carries meaning? Some whisper of panspermia, the idea that life spreads across galaxies by hitchhiking on comets and asteroids, flung from one star to another. If so, Atlas was more than stone and ice. It was a seed, perhaps carrying amino acids, complex molecules, the whispers of biology. Its passage near SWAN might not matter physically, but symbolically, it suggested a connection. Two seeds passing in the night, one born here, one from elsewhere. Others spoke of hidden physics. Could the sun's magnetic sheet act as a kind of attractor, drawing bodies into temporary alignment? Could plasma currents stretch across interstellar space, guiding comets the way trade winds guide ships? Mainstream science resists such leaps, but plasma is a wild master. It does not always obey the neat rules written on chalkboards, and yet, perhaps the most haunting speculation was philosophical. If coincidences this elaborate are possible, what else in our universe is guided by chance that feels like design? Do we live in a cosmos of chaos, or of patterns too vast for us to see fully? Perhaps the line between the two is thin, blurred, indistinguishable. By early October, anticipation built like static before a storm. SWAN brightened again, surging unpredictably, its tail writhing with fresh plasma. Atlas, still invisible behind the sun, crept closer to its moment of revelation. The sun itself remained restless, spitting smaller flares, as if unwilling to return to calm. And humans down on Earth prepared. Amateurs checked their star charts, planning for October's dark skies. Scientists tuned their instruments, scheduling observations for the moment when Atlas might peek free of the sun's glare. Storytellers, mystics and philosophers waited too, their imaginations stirred by the sense that something unusual, perhaps even profound, was about to unfold. For millennia, humanity has looked upward, searching for meaning in alignments. Planets in conjunction, comets in the heavens, eclipses crossing the earth, all were taken as signs, omens, messages from the divine. Today, we frame them in data, in probabilities, in careful language, yet the effect is the same. The sky writes stories and we cannot help but read them. And so, as October approached, the narrative grew heavier. Not just nova and comet, not just flare and CME, but now, interstellar Atlas, a body from beyond, perfectly timed to join the stage. Coincidence or choreography? The answer remained hidden in the days to come, in the dark skies of October 21st, when all the players would converge. By the first days of October, the air among astronomers felt charged, not unlike the atmosphere before a thunderstorm. Each day brought a fresh observation, a new piece of the puzzle, and yet the larger picture refused to resolve. Comet SWAN, still dazzling southern skies, refused to behave like a predictable body of ice and dust. After its first great outburst, it calmed briefly, only to flare again with strange, uneven rhythms. Its tail shifted, twisted, broke apart, and reformed. Photographs from amateurs showed faint disconnection events, as if invisible hands were tugging at its stream of plasma. Seasoned comet watchers muttered to each other, "This one is restless." Atlas, meanwhile, remained hidden in the solar glare, unseen but not forgotten. Computers traced its course relentlessly, simulating hundreds of possible trajectories. Each confirmed what had already been written. Perihelion near the end of October, just inside the orbit of Mars. But what those numbers could not reveal was what Atlas might do once it felt the full furnace of the sun. Would it crumble to fragments like so many comets before it? Would it blaze with a tail brighter than anyone dared predict? Or would it remain stubbornly quiet, a dark stone from another star, indifferent to our hopes? Scientists divided into camps. One insisted the timing was meaningless. "This is randomness doing what randomness does," they said. "When you watch the sky with enough instruments, you will always find clusters, alignments, coincidences." They reminded the public that nova explosions in distant stars have no physical link to comets in our system. They reminded their colleagues that solar flares erupt daily, their timing independent of any external body. But others allowed themselves to wonder. They looked at the sequence of events: nova, comet, flare, CME, and now interstellar visitor, and felt the hairs on their necks rise. Science demands skepticism, but it does not forbid awe. And awe was everywhere. In observatories, plans took shape. Telescopes were scheduled to scan SWAN during its closest approach, hoping to capture the fine details of its tail structure. Radio telescopes prepared to listen for plasma bursts, whispers of electromagnetic interactions echoing across millions of miles. At the same time, instruments around Mars, orbiters, landers, probes, were quietly retasked to monitor Atlas, waiting for the moment when the alien traveler would reveal itself near the sun. On Earth, the anticipation trickled down to amateurs. Astronomy clubs spread word of October's great window. They reminded members to prepare cameras, telescopes, tripods, even binoculars for the new moon night. Forums buzzed with excitement. "Will SWAN rival Hale-Bopp?" one asked. "Could Atlas become the brightest interstellar object ever seen?" another speculated. Meanwhile, among the public, myths stirred. Every generation has read omens in the sky, and the internet amplified them. Some whispered of catastrophe, earthquakes, storms, disruptions. Others spoke of prophecy, of cosmic signs meant to awaken humanity. Rational voices pushed back, but the conversation itself revealed something old and unbroken: our need to make meaning from the heavens. The scientists, for their part, could not entirely silence that instinct within themselves. Even as they drafted papers filled with equations and graphs, even as they checked data streams with rigorous detachment, many admitted privately that the alignment of SWAN and Atlas framed by nova and flare was unsettlingly elegant. It had the feel of story, of deliberate sequence, even if they knew better, and the sun itself refused to quiet. In the first week of October, smaller flares erupted daily, tossing bursts of radiation across space. Nothing catastrophic, but enough to remind watchers that solar cycle 25 was accelerating toward a fever pitch. Magnetometers on Earth jittered, auroras rippled across unexpected latitudes, and satellites adjusted themselves cautiously against the charged wind. All the while, the clock ticked closer to October 21st. The contrast between myth and science grew sharper. In temples, in online groups, in quiet living rooms, some interpreted SWAN's glow as a celestial warning. In laboratories, scientists mapped particle flows, calculated tail angles, and updated probability curves. Yet both groups, separated by method, shared the same restless anticipation. They were waiting. What were they waiting for? Perhaps confirmation, perhaps disruption, perhaps nothing at all. But in their bones, many felt it. October would bring something unusual. There is a paradox in such moments. The more carefully one prepares, the more one heightens expectation, the more likely chance itself begins to look like design. A sudden flare, a shift in a comet's brightness, a meteor shower appearing just on cue, all take on weight when framed by preparation. What might have been dismissed as ordinary becomes extraordinary when eyes and hearts are ready for it. And so humanity stood at the threshold of October's dark window. Instruments tuned, telescopes pointed, myths whispered, hearts unsettled. The stage was set. Was it chaos or choreography? The answer was about to arrive, written in light, fire, and dust. The first nights of October 2025 arrived with the kind of sharp clarity that only autumn skies can bring. Across the southern hemisphere, telescopes whirred to life, their domes turning like silent sentinels. From Chile to South Africa, from Australia to the islands of the Pacific, astronomers, professional and amateur alike, lifted their gaze toward the same patch of sky where comet SWAN traced its glowing path. The comet was alive in a way no chart could capture. Its nucleus burned faintly, too small to resolve even with powerful instruments, but around it stretched a halo of light, a shimmering veil that pulsed and shifted with each passing night. And behind it, the tail. By the time October began, it had grown into a river of pale fire, easily visible in long-exposure photographs, sometimes even to the naked eye from dark rural skies. Observers noticed something strange almost immediately. The tail was not steady. On October 2nd, Australian amateurs reported a sudden kink in its shape, a twisting as though some unseen wind had snapped it sideways. Hours later, photographers in Chile captured the same structure, glowing faint blue against the night. By morning, the distortion had smoothed out, leaving behind a longer, straighter stream. The explanation, at least on paper, was simple: the solar wind. Vast streams of charged particles flowing at hundreds of kilometers per second had caught the comet's ion tail, bending it. Such events were known, even catalogued, but the timing coming so soon after the September flare felt suspiciously on cue. Scientists logged it, reported it, and moved on, but whispers began. Was this the first sign that the chain of coincidences was still unfolding? Meanwhile, Atlas remained hidden behind the sun. No Earth-based telescope could pierce the glare. For most of humanity, it might as well not exist. Yet in the quiet data streams flowing back from spacecraft orbiting Mars, hints began to appear. Spectrometers recorded faint upticks in dust scattering, as though the object was beginning to shed material. It was too early to say for certain, but some analysts began to wonder, had Atlas already begun to outgas, unseen by human eyes? For now, SWAN held center stage. Each night brought fresh photographs, the tail brightening, then fading, then splitting into two distinct strands. Dust lanes crisscrossed the coma, forming patterns like ripples in smoke. To amateurs, it was spectacle. To scientists, it was data. To storytellers, it was omen. In online forums, the old arguments flared again. Some insisted the comet's behavior was nothing unusual, citing past cases like Hale-Bopp and Lovejoy. Others pointed to the extraordinary timing, nova, comet outburst, solar flare, and now fresh disturbances, and declared that the cosmos was sending a message. Memes spread across social platforms, mixing genuine astrophotography with apocalyptic captions. The SWAN sings before the storm. October 21st, the night the sky speaks. Inside observatories, the mood was more disciplined, but no less tense. Teams coordinated nightly. Instruments monitored radio emissions, hoping to catch whispers of plasma waves sweeping from the sun through the comet's environment. Magnetometers on Earth tracked subtle fluctuations in the geomagnetic field. Most nights, the data looked ordinary. But on October 5th, a curious burst appeared in one radio band, a brief spike coinciding with a sudden brightening of SWAN's coma. It lasted less than a minute, then faded. Coincidence? Perhaps. But by now, every coincidence felt heavy. By the end of the first week, it became clear SWAN was restless. It had not settled into the predictable fading curve most comets follow after perihelion. Instead, it pulsed with irregular life, as though each day brought some new disturbance deep within its nucleus. Some argued this was simply the behavior of a fragile, volatile, rich body. Others wondered if it was something more. Atlas remained silent, hidden, and its very silence deepened the mystery. What would it reveal when it finally emerged from behind the sun's glare? And overhead, the sun itself refused to rest. Each day brought smaller flares, minor eruptions, bursts of plasma hurled into space. Nothing catastrophic, not yet, but enough to keep instruments alert, enough to remind everyone that Solar Cycle 25 was building momentum. The first nights of October were not dramatic in the way Hollywood would script them. No skies ablaze, no cataclysmic flares. Instead, they were subtle, uneasy, filled with small disturbances that could be explained individually, but which, when placed together, began to form a pattern. Scientists cautioned restraint. The public leaned toward awe, even fear, and both groups, in their own way, prepared for the dates that loomed ahead. The stage was no longer just being set. The play had begun. By the second week of October, the rhythm of events began to accelerate. The comet's tail bent and twisted in ways that defied easy prediction. Solar flares became almost daily companions, flashing across satellite telemetry with unnerving regularity. And hidden behind the sun, Atlas crept closer to perihelion, its secret still veiled, but its presence undeniable in orbital models. Astronomers spoke in cautious tones. They had lived through cycles of hype before. The great comets that promised brilliance but fizzled, the predictions of solar chaos that never materialized. Yet something about this October felt different. The coincidences were piling too neatly, the timing falling into place with unnerving precision. Even the most grounded scientists found themselves checking the sky with unease. But perhaps the most unsettling aspect was not what was happening now. It was what had happened before. History, it seemed, was whispering warnings. 8 years earlier, in September 2017, the sun had roared awake with a fury not seen in over a decade. An X9.3 solar flare, one of the most powerful on record, erupted on September 6th, followed days later by another almost as strong. The Earth reeled beneath the bombardment. Radio blackouts, auroras far south of their usual haunts, geomagnetic storms rattling satellites and power grids. It would have been remarkable enough, but the universe had more to add. That same week, the first known interstellar visitor, Oumuamua, swept through the inner solar system. A shard from another star, tumbling end over end, it blazed past the sun at 26 kilometers per second. Its trajectory was a hyperbolic escape, proof it came from beyond. To many, its passage felt like a message, a visitor arriving just as the sun released its most violent storms in years. And then, as though echoing some invisible rhythm, the Earth itself shuddered. On September 8th, in the narrow window between the two great solar flares, an 8.2 magnitude earthquake ripped through southern Mexico. The Isthmus of Tehuantepec shook, buildings collapsed, and a tsunami warning briefly swept the Pacific. 3 events: solar cataclysm, interstellar visitor, planetary quake, all within 4 days. Coincidence, said the experts. But to those who lived through it, who watched the sky blaze and felt the ground tremble, it felt like more. The memory of that week haunted October 2025. Was the convergence of SWAN, Atlas, and the restless sun just another echo of the same strange pattern? Were these alignments reminders that the universe sometimes choreographs events that defy statistics? It is in human nature to find patterns, to weave narrative from chance. The ancients read omens in eclipses, portents in comets, destinies in planetary alignments. Modern science replaced mythology with physics, yet the instinct remained. In the digital age, it only grew stronger. By October 12th, the online world was alive with speculation. Amateur astronomers posted night-to-night changes in SWAN's tail, overlaying them with solar flare charts, drawing arrows, circles, connections. Meme makers declared SWAN a cosmic swan song for humanity. Some dug into archives, resurfacing the 2017 parallels. Flares, interstellar visitors, earthquakes. The implication was obvious. History was repeating itself. Scientists countered with measured explanations. Solar activity, they reminded everyone, follows cycles. Comets flare unpredictably all the time. Earthquakes are constant. A magnitude 8 event occurs once every year or two. Coincidence is inevitable when enough variables are in play. But in the public imagination, those explanations only made the mystery sharper. If coincidence alone could create such resonances, what did that say about the fabric of the universe? Was randomness itself a kind of hidden design? On October 13th, Comet SWAN delivered another surprise. For the 3rd time since September, it erupted in brightness. Its magnitude jumped by nearly half a degree, pushing it well into naked-eye visibility for those under dark skies. Its tail, already vast, seemed to fracture into filaments, each glowing faintly blue in long exposure images. Observers compared it to the legendary comets of the past. Some said it reminded them of Hale-Bopp in 1997, whose double tail dominated skies for months. Others recalled Comet Lovejoy, which had survived a near-death plunge into the sun in 2011. But SWAN was different, erratic, unpredictable, bursting to life in pulses as though responding to some unseen command. Theories multiplied. Volatile ices, buried deep within, were being exposed in stages. Internal fractures in the nucleus released sudden geysers of gas and dust. Some whispered of external triggers. Radiation bursts from the recent novas, shock waves from solar activity. None could be proven. all fed the growing sense that SWAN was more than just another comet. Meanwhile, Atlas remained silent, veiled by solar glare. No human eye could see it, but orbiting probes near Mars picked up hints, faint increases in dust, subtle signatures in plasma readings. Some analysts whispered that Atlas might be building a coma larger than anything yet measured, invisible to Earth but ready to explode into visibility once it emerged from conjunction. For now, it was the mystery behind the curtain, the silent counterpart to SWAN's restless song. The symmetry gnawed at observers, one comet visible, one hidden, one native to our solar system, one from beyond, both approaching their critical moments in the same week. Coincidence or choreography? The question repeated like a refrain. As the days of mid-October passed, tension thickened. Each flare from the sun brought questions. Would the plasma clouds intersect SWAN's orbit? Would Atlas feel their shock? Magnetometers ticked upward. Auroras spread southward. Satellites went into protective modes. The global community of astronomers worked tirelessly, sharing data across continents. In Chile, in Hawaii, in the deserts of Australia, long exposures recorded SWAN's every twitch. In laboratories, supercomputers simulated plasma flows across millions of kilometers, trying to predict whether comet and sun were locked in dialogue or dancing in ignorance of each other. And all the while, the 2017 precedent loomed in memory. Blogs, podcasts, documentaries resurfaced it daily. The flares, the visitor, the quake. The past was being used as a template to interpret the present. Even skeptics admitted privately that the pattern was unnerving. Lightning can strike twice, but when it strikes thrice, aligned with celestial visitors and solar storms, even hardened rationalists pause. On October 15th, the halfway point to SWAN's closest approach, the world seemed to hold its breath. In villages with no electricity, people looked up and saw the comet's pale glow. In cities, drowned in light, they scrolled through images online and whispered of omens. In laboratories, scientists compared charts, recalibrated instruments, and braced themselves for what the final week might bring. No disasters had struck, no earthquakes had yet mirrored 2017, but the air was thick with expectation. It was the kind of silence that comes before the storm, the hush before thunder. The question lingered everywhere. Was October 2025 destined to echo the strange convergence of 2017? Or was it simply another trick of pattern, another illusion born of human consciousness reaching for meaning in chaos? The universe, indifferent as ever, kept its secrets, for now. As October's days slipped by, the sky seemed both alive and restrained, as if saving its true spectacle for the appointed hour. SWAN glowed brighter each night, its restless tail bending and twisting under the breath of the solar wind. Atlas still hid, inching toward perihelion behind the sun's glare. Solar flares flashed daily, but none yet reached the furious intensity of September's eruption. Astronomers filled the waiting with stories, and not just stories of myth or prophecy, stories of history, real encounters between comets and the sun that had once rewritten the textbooks, then slowly faded from public memory. If October was to teach humanity something new, they argued, it would be built on the foundations of what the cosmos had already shown us. The year was 2007. Solar cycle 23 was winding down, but the sun still had power left to demonstrate. On April 20th, Comet Encke, a small periodic comet that returns every 3.3 years, was making one of its routine passages through the inner solar system. Its faint ion tail streamed millions of kilometers into space, a delicate filament tethered to the nucleus by invisible lines of magnetism. And then, the storm came. From the sun erupted a coronal mass ejection, a billion-ton bubble of magnetized plasma, racing outward at over 2 million miles per hour. As the CME expanded into interplanetary space, it slammed into Encke's fragile tail with surgical precision. The event was captured by the twin stereo spacecraft, which had been launched the year before to study solar eruptions in 3 dimensions. What the spacecraft recorded stunned astronomers. Within hours, the CME tore Encke's ion tail completely away from its nucleus. The brilliant streamer of charged gas snapped, severed like a ribbon in the wind. For a time, the comet trailed nothing at all, its nucleus stripped bare. Only after the storm passed did new material stream outward, slowly rebuilding the luminous tail. It was the first time humanity had ever witnessed such an event in real time, a comet S-tail, severed by the sun. Proof in vivid clarity that the interaction between comets and solar plasma was more violent and complex than theory had imagined. To some, the 2007 disconnection was a curiosity, a footnote in heliophysics. To others, it was a revelation. It showed that comets were not passive wanderers, but active participants in the drama of space weather. They were not just victims of the solar wind. They were test particles, probes, their fragile tails tracing invisible magnetic structures across millions of miles. 7 years later, in 2014, the universe offered another lesson, this time at Mars. Comet C2013A1, better known as Siding Spring, came from the Oort cloud, the distant reservoir of icy bodies at the edge of the solar system. Its orbit carried it on a million-year plunge into the inner solar system, and by chance, it would pass extremely close to Mars, closer than any comet had ever been observed to pass a planet. On October 19, 2014, Siding Spring missed Mars by just 87,000 miles, about a third of the distance between Earth and the Moon. For a planet, that is a near miss. For Mars, it was a storm. The coma of gas and dust enveloped the red planet, and instruments orbiting Mars recorded chaos. Metallic ions flooded the upper atmosphere. The planet's thin air was bombarded with dust grains traveling at dozens of kilometers per second, triggering the most intense meteor storm in Martian history. NASA's MAVEN spacecraft, designed to study the Martian atmosphere, flew directly through the coma, measuring chemical changes and electromagnetic disturbances. The results were shocking. Mars's atmosphere was heated by hundreds of degrees. Its ionosphere scrambled, its magnetic environment rewritten by the passage of the comet. For weeks afterward, scientists studied the data, realizing that comets carried far more power than their icy appearance suggested. A single pass had reshaped an entire planetary environment, briefly but measurably. These episodes should have changed the way we think about comets. They showed that a coronal mass ejection could rip a comet's tail from its body in hours. A single outgassing object could alter the atmosphere of an entire planet. Plasma, magnetism, and dust combined in ways that defied the neat equations of textbooks. And yet, in the years that followed, both events faded from memory. To the general public, they were never more than fleeting headlines. Even among scientists, they became niche examples, referenced in specialized papers, but rarely entering the larger conversation. Until now. As SWAN flickered and Atlas approached, researchers returned to the archives. They replayed the stereo movies of Enki's tail being severed. They reanalyzed Maven's plasma data from the Siding Spring encounter. And they asked, what if October 2025 brought something similar, but larger? By October 17th, SWAN was clearly unstable again. Its tail displayed odd kinks, sudden bright spots that shifted night by night. Photographs taken in South Africa showed what looked like the beginning of a tail disconnection, faint but unmistakable. Within hours, a geomagnetic storm rippled across Earth, triggered by another moderate solar flare. Coincidence, maybe, but those who remembered Enki whispered otherwise. Meanwhile, word filtered from ESA's Mars orbiters. Atlas was showing signs of coma formation, faint gas, faint dust, but enough to suggest it was waking up. The parallel was irresistible. SWAN, a solar system native, restless and unstable. Atlas, an interstellar visitor stirring behind the sun, both within weeks of their most dramatic encounters. And overhead, the sun itself seemed to be watching. For those who knew the forgotten stories, October felt like déjà vu. Enki's disconnection, Siding Spring's storm, they were not isolated curiosities, but warnings. Comets were not passive. They were keys to understanding the electromagnetic machinery of the solar system. Perhaps SWAN's tail would be severed as Enki's had been. Perhaps Atlas, like Siding Spring, would drape a planet in dust and plasma. Perhaps the sun would use them both as instruments, amplifying its own rhythms in ways that defied chance. The history was there, written in data and memory. The question was whether October 2025 would add a new chapter or repeat the old ones louder. The waiting continued. The dates drew closer. And humanity, whether through telescopes or bare eyes, braced itself for the curtain to rise. The September novas still haunted the minds of astronomers as October unfolded. Two stars in distant constellations had erupted almost back-to-back, their violent thermonuclear flashes releasing floods of gamma rays and X-rays into space. The light from those explosions had crossed thousands of years to arrive in our skies just days before SWAN's sudden awakening, just before the sun's own flare shook the heliosphere. To dismiss it as coincidence was easy. To prove it as anything more was nearly impossible. The radiation from even the brightest nova, diluted by distance, was vanishingly small compared to the steady torrent of photons pouring from the sun every second. At Earth, the nova's contribution was like a candle flickering against the blaze of a furnace. By the ordinary measures of energy, such light could never disturb a star as vast as our sun, or a comet already bathed in solar heat. And yet, the sequence refused to let go of the imagination. For thousands of years, humanity had built meaning from celestial timing, eclipses coinciding with battles, comets rising with kings, alignments appearing just before plagues or famines. Modern science had dismissed those patterns as superstition, the product of minds wired to seek cause where only chance existed. But even scientists are human, and the temptation to wonder, to look again at the timing of the novas and the flares, gnawed at the edges of certainty. Perhaps it was not about the raw power of nova light. Perhaps it was about thresholds. The sun's active regions simmer for days, weeks, sometimes months, storing magnetic energy in twisted loops of plasma. They balance on the edge of eruption, waiting for a trigger. What if even a tiny external push, A subtle change in ionization, a whisper of added energy from photons arriving at just the wrong or right moment, could upset that balance. The nova light would not need to overpower the sun. It would only need to arrive at the precise instant when instability teetered into eruption. Some physicists laughed at the idea. The scale mismatch was absurd, they argued. 1 trillion photons from a nova could not rival the energy released in one heartbeat of solar fusion. Others, though, remembered the lessons of complex systems. Avalanches begin with small cracks. Earthquakes can be unleashed by the faintest tremor. A match does not create a forest, but at the right moment it can ignite one. As the debate deepened, historical records were quietly reopened. Old catalogues of nova events were cross-referenced with solar flare archives, looking for coincidences hidden in the noise of centuries. Patterns emerged, faint but intriguing. On more than one occasion, a bright nova had been recorded just weeks before a surge of unusual solar activity. The sample sizes were small, the uncertainties immense, but the coincidences were enough to stir whispers. October 2025 added fuel to the whispers. The novas of September had shone, SWAN had flared, the sun had erupted. Now Atlas moved silently toward perihelion, the last player in a sequence that felt almost scripted, and the waiting world asked the forbidden question: could these events be linked, bound not just by chance but by some deeper, hidden architecture of energy? The problem, as always, was evidence. Without measurable signatures, unique emissions, correlations repeated across multiple cycles, anomalies too consistent to ignore, the theory remained speculation. Most observatories treated it as such, noting it in conversations but not daring to publish. Others leaned into the mystery, drafting papers that speculated about nova photons penetrating cometary nuclei, triggering buried volatiles, or altering plasma balances in the solar corona. These theories stretched physics, but in stretching, they provoked new lines of observation, new questions that might otherwise have been left unasked. Skeptics pointed to human psychology. People remember coincidences that feel significant and forget the countless times nothing happened. For every nova that appeared before a flare, there were dozens that passed unnoticed. For every comet that brightened at a curious moment, there were hundreds that behaved in ordinary ways. To link them required careful statistical proof, not instinct. But others countered that the universe itself may work in rhythms too subtle to be captured by crude averages. Perhaps the cosmos was more like an orchestra than a random machine, with instruments playing themes and variations across scales of time and distance. What appears random at one scale may reveal resonance at another. The novas were distant horns, the comets drifting violins, the sun the drum at the center. And October, for reasons we did not yet understand, was the moment when the music swelled together. Night after night, SWAN continued to pulse with erratic brightness. Some observers noted shifts in its ion tail that seemed to match the arrival times of solar wind disturbances traced back to flares days earlier. Coincidence again, or feedback? Without in situ probes near the comet, the answer was guesswork. Yet the images were haunting. A tail bent here, a sudden dimming there, each seeming to echo events unfolding millions of kilometers away at the sun. Atlas remained silent, still hidden, but models predicted it too would soon enter its most vulnerable stage. If it was volatile-rich, it might burst to life dramatically as it neared perihelion. If not, it might remain a dark stone, a disappointment to those hoping for spectacle. Either way, the timing was cruelly precise. Its awakening, if it came, would coincide almost exactly with SWAN's closest approach to Earth and with the peak of solar unrest. The nova-solar coupling theory hovered over all of this like a ghost. Officially, it was dismissed. Unofficially, it colored every conversation. Journalists hinted at it in articles, careful to say speculative, but eager to spark imagination. Amateur forums embraced it openly, some even building countdowns to October 21st, the night of the new moon, the night when SWAN would be brightest and Atlas closest to revealing itself. And above all of it, the sun continued to stir. Small flares burst daily, magnetometers ticked with restlessness, auroras painted the skies over Canada, Scandinavia, and even Northern Europe. Space weather forecasters warned airlines of possible radio blackouts, warned satellite operators of increased drag, warned power companies to prepare for geomagnetic storms. None of these events were unprecedented, but together they painted a picture of a star climbing toward frenzy. By October 18th, just days before SWAN's closest approach, the question was no longer whether coincidence existed. The question was how far one was willing to follow its trail. For some, the novas were forgotten, dismissed as irrelevant sparks from distant suns. For others, they were the opening notes of a composition still unfolding, a reminder that in a universe of plasma, magnetism, and resonance, distance may not matter as much as we once thought. The coming nights would decide which vision of reality held sway, the universe of randomness or the universe of hidden connections. Perhaps they were the same thing, viewed through different eyes. Perhaps the line between coincidence and causation was thinner than we dared to admit, and so the nova light faded from memory, but its echo remained, woven into the restless sky of October. SWAN burned. Atlas approached. The sun roared. The world waited. The 19th of October dawned quietly on Earth, but in the silent space around Mars, a stranger stirred. For weeks, Atlas had hidden behind the glare of the sun, invisible to human telescopes, its presence marked only by equations and projections. But now, at last, the geometry shifted. Slowly, delicately, the comet's faint coma began to peek into view, rising from the curtain of light that had veiled it. At first, it was barely a whisper, a dim blur recorded by the Mars Reconnaissance Orbiter, its instruments tuned for geology, but sensitive enough to detect faint changes in brightness against the black. Then ESA's trace gas orbiter caught a spectrum, a thin signature of cyanide and carbon monoxide in its coma. Alien molecules, yes, but also familiar. Comets, after all, are chemical cousins, whether from our own Oort cloud or from another star's nursery. Yet even in their familiarity, these molecules carried a weight. They had been forged elsewhere under the light of a distant sun, bound into ice long before Earth itself had formed. Atlas brightened rapidly, faster than expected. Its coma expanded with each hour, pushing outward in an irregular shape. Some scientists whispered that it might be fragmenting, its nucleus cracking under the sun's heat. Others argued it was simply volatile rich, its surface bursting with pockets of gas. Whatever the explanation, its behavior was not like Borisov, the first interstellar comet, which had brightened steadily but calmly. Atlas was erratic, restless, unpredictable, more like SWAN than anyone wanted to admit. The timing made the connection unavoidable. SWAN, unstable, volatile, pulsing with eruptions. Atlas, interstellar, newly awakened, echoing the same behavior as it drew close to the Sun. Two comets, one born of our own system, one from another, flaring together in October's restless skies. To say it was coincidence felt like a defense mechanism, a shield against awe. To suggest choreography risked ridicule. But the sense of story was undeniable. On Earth, SWAN continued to hold its audience. Each night, its tail stretched longer, now clearly visible to the naked eye in rural skies. Photographers compared its pale streamer to a sword, a cosmic brushstroke across the heavens. Yet even as its beauty grew, its core flickered strangely, bright one night, faint the next. Amateur astronomers debated fiercely, was the comet breaking apart, or simply venting unevenly as jets carved holes in its icy skin? Meanwhile, the Sun itself had not calmed. On October 19th, an X-class flare erupted from active region 4234. Instruments recorded the surge of X-rays, and minutes later, Earth's ionosphere shuddered again. Radio operators lost contact for nearly half an hour. Planes rerouted. Satellites went into safe mode. Auroras lit up skies as far south as Germany, surprising even seasoned forecasters. The flare carried a coronal mass ejection, a massive bubble of plasma racing outward. Its trajectory was not earthward, but westward, directly into the corridor where Atlas was climbing toward perihelion. Once again, a storm and a comet intersected, as though the Sun itself were acknowledging the newcomer, hurling a greeting or a warning. The parallels to 2007's Enki disconnection and 2014's Siding Spring storm at Mars were not lost on the scientific community. If the CME struck Atlas's coma, it could strip material, sever its forming tail, or trigger fresh eruptions. Instruments aboard Mars orbiters braced for impact, their operators holding their breath as the plasma waves swept across. The data trickled in over hours. MAVEN detected spikes in ionization, bursts of plasma density far above baseline. The comet, it seemed, was shedding more than expected, feeding particles into the surrounding medium. Some of those particles interacted with Mars's own tenuous atmosphere, sparking faint auroras, visible only to sensitive cameras. Mars had become briefly part of the drama. Its sky lit not by its own magnetism, but by the breath of an interstellar wanderer meeting the fury of the Sun. On Earth, the reports spread quickly. Headlines declared Atlas a volatile alien visitor, restless interstellar comet, cosmic stranger stirring Mars's skies. For the first time since its detection, Atlas captured public imagination. SWAN had been the spectacle of the eye, but Atlas became the spectacle of the mind, a body from beyond, behaving wildly as it neared our star, and the symmetry deepened. October 21st approached, the date whispered since September. SWAN at its closest to Earth, Atlas at perihelion, the Sun restless, the Moon dark. No mythmaker could have chosen the timing better. The coincidence was unbearable, the choreography irresistible. Even those who mocked it could not stop speaking of it. In forums, speculation spiraled. Was Atlas carrying alien chemistry unseen in our system? Could its dust contain amino acids from another star's cradle? Was its sudden volatility a sign of fragility, or a message written in physics too complex for us to decode? In laboratories, the mood was more measured but no less urgent. Teams processed spectra, calibrating for faint anomalies. A hint of diatomic carbon here, a trace of hydrocarbons there, not alien in essence, but alien in origin. These were the fingerprints of a different nursery, a different protoplanetary disk, frozen billions of years ago and carried to us only now. Atlas was a fragment of another world, another time now unraveling in our skies. And so the days narrowed, SWAN brightened further, Atlas grew restless, the sun flared, and Earth waited. The week of October 21st was no longer a distant date. It was tomorrow's horizon. The stage was complete. The 20th of October carried with it a strange electricity, not only in the data pouring from satellites, but in the very air of Earth itself. News outlets across continents ran the same stories, some careful and scientific, others sensational and apocalyptic. Comet SWAN, visible to the naked eye, was brighter than at any point in its passage. Atlas, the alien visitor, was rounding the sun at perilous proximity, its coma flaring into an irregular cloud caught in the solar wind. The sun itself remained restless, an orchestra of flares and minor storms building like drums before a crescendo. For most of humanity, it was a day like any other. Cars moved, screens flickered, conversations carried on. Yet in observatories, in backyards with telescopes, in fields where rural skies still revealed their secrets, there was a shared sense of anticipation that bordered on reverence. Something was about to happen, though no one could say what. By nightfall, the Earth turned its face toward the dark moon. October 21st had begun. The sky was ink black, stripped of lunar glow. From countryside roads in South America, from deserts in Australia, from savannas in Africa, eyes lifted, and there it was. SWAN, shining faint but steady, its tail stretched long across the heavens. A river of light, a whisper of ice and dust carried on the solar wind, a reminder that the solar system was not quiet, but alive with motion and fragility. For many who had never seen a comet before, it was transformative. Photographs could not capture the way it shimmered, the way its brightness seemed alive, pulsing faintly against the stars. Children pointed. Elders remembered other comets, Hale-Bopp, Halley, but admitted this one felt different. Perhaps it was the timing, the darkness of the moon, the context of the novas and flares. Perhaps it was simply the story humanity had built around it. But to those who saw it, SWAN was not a distant object. It was a messenger. High above Mars, Atlas was completing its turn. Its perihelion passage was violent. Instruments detected sudden brightening as jets of gas ripped from its surface, some so intense they fractured its coma into multiple lobes. Dust streamed outward, some grains larger than expected, tumbling in chaotic spirals. The alien visitor was unraveling, exposing its frozen heart under the sun's relentless heat. ESA's orbiter recorded spikes in unusual hydrocarbons, faint but present, molecules rare in comets of our own system, carried intact across interstellar space. It was as if Atlas, in dying, was releasing a secret it had carried for eons, a whisper of chemistry from another cradle of planets. The data would take months to analyze, but even in raw form, it was enough to ignite speculation. Life's building blocks might not be unique to our star. The seeds could drift between systems hidden in icy stones, waiting for the right world to fall upon. And as if to punctuate the drama, the sun spoke again. On the evening of the 21st, Solar monitors recorded an X 2.1 flare. Its eruption was not Earth-directed, but it poured energy into the heliospheric current sheet, the same vast electromagnetic boundary where both SWAN and Atlas lingered. The flare's light reached Earth in minutes, ionizing the atmosphere, producing a brief radio blackout across the Pacific. Hours later, auroras shimmered in places unaccustomed to them: Japan, northern India, even faintly in the skies over Turkey. Observers could not ignore the symmetry. Two comets, one native, one interstellar, both active, both visible in their own way. A restless sun, flaring in the same corridor that contained them. A darkened moon amplifying the spectacle. And above it all, the echo of September's novas still lingered in human memory. For astronomers, the convergence was intoxicating. They raced to collect every possible scrap of data. Long exposures of SWAN revealed ripples in its tail, oscillations that seemed timed with the solar wind's fluctuations. Spectra of Atlas hinted at chemistry unlike any seen before. Magnetometers traced disturbances racing through Earth's field, signatures of plasma flows that may have been nudged by cometary mass loading. None of it was proof of connection. All of it felt connected. For the public, it was something simpler: awe. Social media filled with photographs of SWAN above city skylines, faint but undeniable, a reminder of the cosmos hanging overhead. Hashtags trended. Memes collided with genuine wonder. Some posted poetry, others predictions of doom. But beneath it all was a shared astonishment that in an ordinary week of life, the universe had unveiled a spectacle so rare, so perfectly timed, it could not be ignored. And for those who remembered 2017, there was unease. That year it had been flares, an interstellar visitor, and an earthquake. This year it was novas, comets, flares again. Would the Earth itself echo the pattern? Scientists cautioned against such thinking, but whispers spread nonetheless. Some waited not for auroras or photographs, but for tremors, storms, disruptions, the shadow of history repeating itself. As midnight passed and October 21st deepened, telescopes continued their vigil. SWAN burned, Atlas fractured, the sun flared. The convergence was real, undeniable, written not in imagination but in data, photons, plasma. The question was no longer whether it was happening. The question was what it meant. The night passed, and dawn began to creep across continents. But the story was not over. For though the comets would soon begin to fade, though the flares would pass, though Atlas would vanish back into interstellar darkness, the memory of October 21st would remain, a night when coincidence and choreography became indistinguishable, when humanity looked up and felt for a brief moment that the universe was speaking in patterns too deliberate to ignore. The night of October 21st passed into memory as dawn touched the world, but its images lingered in the minds of those who had witnessed it. For a brief span of hours, the universe had felt orchestrated. Two comets blazing in tandem, the sun flaring in rhythm, the moon absent to deepen the view. It was a convergence so clean, so unlikely, that even the skeptics spoke of it with a trace of awe. Yet the cosmos does not pause for human wonder. It moves on, indifferent, and by the days that followed, the great spectacle began to unravel. Comet SWAN was the first to show signs of decline. Its coma, so bright in the nights of mid-October, began to dim. At first the change was subtle, noticed only by careful measurements. Photographs compared side by side showed a tail a little less defined, a coma a little less brilliant. By October 25th, the difference was plain even to amateurs. The comet was retreating, its brightest days behind it. What had burned so fiercely was now cooling, fading back into the silence from which it had come. But even in fading, SWAN was not steady. It flickered with smaller outbursts, sudden jumps in brightness that lasted hours, then fell again. Its nucleus seemed fragile, perhaps fractured, releasing jets at odd intervals. Some astronomers speculated that the comet was breaking apart, shedding fragments too small to track, but enough to cause turbulence in its glow. Others said it was only exhaustion, the natural course of a body that had given too much too quickly. Whatever the cause, its final weeks were restless, a swan song in the truest sense. Atlas, meanwhile, endured a harsher fate. Its perihelion passage near Mars had stripped it of stability. The data from orbiters grew stranger by the day. Spikes in dust levels, irregular plasma surges, sudden dips in brightness, all pointed to a nucleus under stress. Then, on October 23rd, a dramatic event was recorded. For several hours, Atlas brightened sharply, its coma swelling to nearly twice its previous size, and then just as quickly it faded. Images from Earth-based telescopes, finally able to glimpse it in the post-perihelion sky, showed a diffuse cloud rather than a sharp nucleus. Atlas was gone, its body shattered, reduced to a spreading trail of debris vanishing into the void. The alien visitor had arrived, revealed its secrets, and died in the fire of our sun. It would not return. Its fragments would drift unseen, swept into the currents of the solar wind, absorbed into the endless medium between planets. In its brief life as a spectacle, it had offered humanity a glimpse of material from another star. Chemistry forged in a nursery beyond imagination. But its story, like SWAN's, was brief. By November, Atlas too would be nothing more than a memory. The sun, restless still, continued to flare. Smaller eruptions dotted the days that followed, but none as dramatic as the October 21st event. It was as though the star itself had exhaled, released its tension in a sequence of storms, and now settled back into its familiar rhythm of turbulence and calm. Yet even in its relative quiet, it had reminded humanity that it was the true power in this alignment, the furnace that made comets shine, the drumbeat that set the pace of the sky's performance. And Earth, caught in the middle, reflected. Scientists processed terabytes of data. They dissected SWAN's light curves, Atlas's spectra, the sun's plasma flows. They debated the nova-solar connection, the possibility of cometary influence on solar activity, the meaning of alignments that seemed too neat to dismiss. Some papers leaned toward chance, reminding readers of the countless coincidences unnoticed in the background of cosmic history. Others leaned into speculation, daring to ask if subtle triggers or hidden resonances connected these events across scales we barely understood. The public conversation was less restrained. For weeks afterward, social media buzzed with theories. Some declared the convergence a warning, a cosmic omen ignored by the powerful. Others insisted it was proof of panspermia, of life seeded across the galaxy by visitors like Atlas. A few, more poetic, simply said that for one night, humanity had been reminded of its smallness and of its belonging to something vast. In villages and cities alike, people remembered looking up at SWAN's pale glow, And though most would forget the details, the flares, the novas, the data streams, they would not forget the feeling. For a moment, the sky had felt alive, speaking in patterns that defied indifference. And yet, as always, time smoothed the edges. By December, SWAN was too faint to see without strong telescopes. Atlas was gone entirely, its remnants invisible. The sun continued its cycle, still active, still unpredictable, but now stripped of the aura of synchronicity that October had given it. Life on Earth resumed its rhythms. News cycles moved on. The great alignment faded into history, but not for everyone. In observatories, in university labs, in quiet corners of the internet, the memory remained alive. Data was archived, waiting for years of analysis. Theories were drafted, some to be dismissed, others perhaps to spark new discoveries. And in the hearts of those who had felt the October nights directly, the question lingered, unresolved and unresolvable. Was it all coincidence, or was it a message? Perhaps the universe is indifferent, its patterns random, its alignments meaningless. Perhaps. But on that night of October 21st, as SWAN glowed, as Atlas shattered, as the sun flared, it had not felt meaningless. It had felt like story, like choreography, like a whisper written in light and plasma across the sky. And maybe that is what matters most. Not whether the cosmos truly speaks, but whether we are willing to listen. When November settled in and the last echoes of October's convergence faded from the sky, the universe looked as it always had. The stars burned with their steady light. The planets traced their paths with quiet indifference. The sun rose and set, blazing in its ordinary rhythm. To the casual eye, nothing remained of the drama that had consumed astronomers, dreamers, and storytellers just weeks before. Comet SWAN drifted outward, a fading ember. It had once stretched its luminous tail across the heavens, a sword of light that seemed unbreakable. Now it was little more than a dim smear, lost in the glare of the sun or drowned in the brightness of Earth's skies. Its nucleus, fractured and exhausted, would return to darkness, circling silently until its next encounter, or until it shattered completely and became dust. Its story, brilliant and brief, had ended. Atlas had no return. The interstellar visitor was gone, scattered into invisible fragments carried away by the solar wind. Its chemistry, its molecules, its alien fingerprints were preserved only in the data stored on hard drives, to be studied and debated for decades. What had once been a coherent body, a messenger from another star, was now only a memory. It had come, revealed itself, and vanished forever, leaving Earth with nothing but questions. The sun, too, continued its cycle, its flares and storms no longer tied in human minds to novas or comets. It was still restless, still dangerous, still beautiful, but stripped of the sense of choreography that October had given it. In the cold light of later months, its eruptions looked ordinary again. Numbers on charts, spikes on graphs, not movements in a cosmic symphony. And yet for those who had watched closely, who had felt the weight of those weeks, the memory refused to die. It was not simply about comets or flares or novas. It was about the way they had aligned, the way their timings had echoed one another, the way they had felt like story. Humans are not content with data alone. We need meaning. And October had given us meaning in abundance, even if it had come only from our own longing to find it. Perhaps that is the secret the sky has always held. The heavens move according to physics, indifferent and vast, but when we look up, we weave them into tales. To the ancients, comets were omens, novas were divine fire, flares were the anger of gods. To us they are plasma, nuclear fusion, gravitational coincidence, yet the effect is the same. They remind us of our place, our fragility, our hunger for narrative in a universe that gives us none. And maybe, just maybe, the narratives are not illusions. Maybe the universe does not speak in words, but in resonances. Maybe coincidences are not tricks, but patterns too complex for us to measure. Perhaps a nova's light can arrive at the moment a comet falters. Perhaps a comet S plasma can stir the current sheet at just the moment a flare is ready to break. Perhaps interstellar fragments cross our skies, not randomly, but in rhythms we have yet to perceive. We cannot prove it, perhaps we never will. But in the absence of certainty, story fills the gap, and story has power. For one night on October 21st, billions of people lived under the same dark sky. Some looked directly at SWAN, some watched photographs online, some read reports of Atlas near Mars, some felt the auroras above their heads. Most simply carried on, unaware. But for those who paused, who lifted their gaze, there was a shared moment of awe. The rare, fragile recognition that the universe is vast and alive, and that we are part of it. And perhaps that is the true meaning of the convergence. Not that it was a warning, not that it was a message, but that it reminded us briefly and beautifully to look upward. The cosmos will continue its rhythms indifferent to our wonder. Stars will flare, comets will fracture, novas will burn in distant silence. Interstellar fragments will pass, unnoticed, into the dark. The sun will rage and rest again. The earth will turn, and humanity will keep searching for patterns, for connections, for the sense that we are woven into the story. Maybe we are. Maybe the story is real. Maybe coincidence is choreography. Or maybe it is not. But in the end, it hardly matters. Because for those who lived through the restless weeks of October 2025, who saw SWAN's glow, who imagined Atlas unraveling at the sun, who felt the auroras ripple across the sky, the memory is enough. The silent sky carries no answers, but it carries the echo of questions that refuse to die. And that, perhaps, is its greatest gift.